Hey y'all, we're going to be continuing the unit on polynomial equations, and so we have to continue our understanding of factoring. And so we're going to build off of the previous lesson on factoring trinomials with this lesson on factoring using substitution. So I'm showing you 4 different problems that look a little bit nutty, and we can apply what we had learned with factoring trinomials to these nutty looking polynomials by using something called substitution. And the way substitution works is that you treat things as if they were what's called the quadratic trinomial. So if you treat things like a quadratic trinomial, you can use substitution to do that, and then we'll be able to successfully factor some things out. So if we look at just a brief refresher on a quadratic trinomial is what we factored previously. So the quadratic trinomial was in the form of ax squared plus bx plus c, and we learned all of the different methods to factor that trinomial to express it as a product of 2 binomials. And we can use substitution as a way to do that. So, for example, if we said, just for an example, if we said, hey, factor x squared plus 3x minus, I don't know, let's see, 3 and 4 and 1, how about 4? Okay, so x squared minus, or plus 3x minus 4, and we wanted to factor that expression, we could actually substitute an x with an a. Okay, so this is what, or any other variable for that matter. So we can use substitution. Let's say x is a, then we can rewrite this as a squared plus 3a minus 4. And then we can factor this, right? We can totally factor this using any method we want. You can use the x factor. You can factor by grouping. You can use mental math. Me, I'm going to use mental math. And so I'll have an a here and an a there. And I'm thinking, what 2 numbers multiply to -4 but add to positive 3? That would be a positive 4 and a -1. So I had factored that using mental math, but it doesn't matter which method you use, you'll get to this binomial, this pair of binomials being multiplied. But remember what we did. We had said, let's say x is a, and so we changed it. Now we just switch it back, right? So now we can just switch back to x, and then we're good to go. So we can switch back to x, and that's the process. So when we switch back to x, we'll have, okay, well then x plus 4 times x minus 1, and that is our factored expression. Okay, so there's nothing fancy in that example. I'm just saying we could use substitution in that way because we can work with something else, then just go back to what we said a was representing. Now, why is that important? Hopefully you do realize that is important, so don't think it's not. It's hugely important. Because if we look at these examples, we can substitute a for all sorts of crazy stuff. So if you look at what's happening there, a can be substituted for a lot of nutty things. So now what we can do is look at problem number 1, and then we have x to the 4th minus x squared minus 20, and we don't know how to factor stuff that's x to the 4th, right? But what if we said, hey, take a look at that middle term. Take a look at that b. It's an x squared. What if we said, let's just say that a is x squared. Okay, let's just say that a is x squared. So what's going to happen in that middle term? Instead of saying x squared, we're going to have a minus a and then minus 20. But what would be the first term, right? The first term is x to the 4th. But if x squared is a, guess what x to the 4th is in terms of a? It's actually a squared. So knowing how laws of exponents work, that's going to help us in quite a bit of situations there. Remembering how laws of exponents work because remember a note x squared to the 2nd power is actually x to the fourth, right? That's the note we have to remember from laws of exponents to see how this substitution piece works. And so it's recognizing that we can do that in this situation. It's going to set this trinomial up to be factored easily, right? Now we can factor a squared minus a minus 20. So if you have a hard time understanding what just happened here, hit pause on the video and make sure you understand what's being written here, what's being written here, and how this relates to each other. That's a huge deal. So you want to probably hit pause to understand that fully. Once we have that, let's factor this bad boy, right? So now we're going to factor this out. And it doesn't matter which method you use. X factor, factor by grouping, mental math, whatever. It doesn't matter to me. So when we factor this out, I'm going to use mental math. What two numbers multiply to negative 20 but add to negative 1? I'm thinking 5 and 4, but the negative must be the bigger number, so it's a minus 5 and a plus 4. Okay, so that's how I'm going to factor that using mental math. But I'm not done yet, because what we need to do now is switch back. Okay, so now we can switch back. And when we switch back, remember what we had said. We said a is x squared. Well, now we have a minus 5 and a plus 4, so we switch back and say, okay, well then it's actually x squared minus 5 and then x squared plus 4. Ta-da! And we have now factored this out. Unless there's a way we can factor these, but we can't. Okay, so these can't be factored, we're done. All right, so these can't be factored, we're done. Can no longer factor, therefore we are done. We are done. And that's going to set us up beautifully for graphing. Trust me, this sets us up beautifully for graphing. So we are done. That is the factored expression that we began with. So it's recognizing how we can get to a trinomial, a quadratic trinomial. And so if we can find a way to get our original expression into a quadratic trinomial, we're set to go. All right, so that's how that works. Now what we can do is look at number 2. If you remember the equation, or the expression number 2 was x to the 6th minus 4x to the 3rd minus 12. How can we factor that? Well, clearly we have a trinomial. That's cool. But can we turn it into a quadratic trinomial? And can we turn it into a quadratic trinomial? Can we set it up to where what we're looking at is minus 4a? You know, that would be a good idea. And there is a way. Well, we can say that, let's say a is x to the 3rd power. So we're going to say that. Let's say a is x to the 3rd power. Right? So if we say a is x to the 3rd power, what will that mean for x to the 6th? Well, another note. Laws of exponents. Did you remember that x to the 3rd power squared is x to the 6th? Did you remember that? So hopefully you do, because if you remember that, then it's clear to see, well then, this first term, instead of saying x to the 6th, is actually going to be a squared. Ta-da! So the first term is actually going to be a squared, and then we have a squared minus 4a minus 12. And we are set to factor because now we have a quadratic trinomial. All right, so now we're ready to factor. And this is challenging, I'm not going to lie. The ability to see that this is possible is a challenging ability. So the important thing to do is your homework, right? So make sure you practice this as much as you can. So now we can factor a squared minus 4a minus 12. And we can, again, I'm going to use mental math. If the lead coefficient's 1, I'm using mental math. This is how that goes. So I set up my mental math. And I'm thinking, what two numbers multiply to negative 12 but add to negative 4? And at first I might think 4 and 3, but that ain't going to work. 6 and 2, though, now we're in business, right? So we have 6 and 2 multiplied to 12, but if I had the negative 6 and the positive 2, that would be perfect. That would be my money. So there we go. So we have factored out that trinomial. And now what we're ready to do is switch back. And so we have factored our trinomial. We switch back. because we had used a as a, we were saying a is x to the third power, so now we just put the third powers back where they belong. And so we have x to the third power minus 6, and then x to the third power plus 2. Neither of these can be factored, all right? So neither of them can be factored. We're done, all right? So neither can be factored. We're done. And only then, once you determine that, only then do you know we are done. And then we have set ourselves up beautifully for graphing. Okay, so that's a beautiful graphing situation. All right, so that's how that works. Now, that's the concept of factoring using substitution. But what about number 3 and number 4? So look at those crazy things, right? So let's take a look at these. This is what's going to be fun. If we have polynomials involved with some crazy stuff, are you able to see what we can substitute, right? Hopefully you have the vision of the substitution piece. So how can we turn this into a quadratic trinomial? So do you have the vision to see, if only this said, if only the middle term, instead of saying 5 times 3x minus 1, if only the middle term said plus 5 times a. Man, if it was that, we'd be good to go. So you know what we can say? Let's say, right? Let's say that a is actually 3x minus 1. If we say that a is actually 3x minus 1, that's what we're doing here. We have a beautiful, beautiful setup. That means that first term is going to be a squared, and of course the constant, that's not going to change, it's plus 6, right? So now we're ready to factor. How perfect is that? And this is the hard part right there. So having the vision to see that if we say a is 3x minus 1, such a good place to be. So now we can factor this. Again, I'm going to use mental math. Two numbers that multiply to 6, add to 5, positive 3, positive 2. And all we do now is switch back. This is where things are going to be a little crazy. So now we're going to switch back. If we switch back, we're going to have this. Check this noise. Instead of saying a plus 3, what are we going to have? We're going to have 3x minus 1 plus 3. And then instead of saying a plus 2, we're going to have 3x minus 1 plus 2. Right? And are we done? Of course not. We can't be done. That's crazy talk. That's crazy talk. That is not going to help me graph anything, right? This is not going to help me graph or solve anything. So what do we do now? We can simplify, right? We can totally simplify each factor. So simplify each factor, and then we're good to go. So our first factor, we have 3x minus 1 plus 3, or 3x plus 2. And the second factor, 3x minus 1 plus 2, or 3x plus 1. So when we have factored out that crazy looking trinomial, when we use substitution, we're actually going to end up with these two factors, and we are now set perfectly for graphing or solving. But we'll get to that later. But either way, this is good, right? So we have used substitution there. Isn't that fun? That should be fun. I think it's fun. I'm a nerd. You should be too. Anyway, so that's how substitution works for that, and we'll do the same thing with the last expression. So we have 3x plus 6 to the second power plus 12 times 3x plus 6, and then minus 28. And it's such a strange problem, because if you see what we're going to substitute, doesn't it have a common factor? Yes, but anyway, that's not the point. The point is, can we use substitution to factor this trinomial? All right, so we're going to be factoring this trinomial. How cool would it be if instead of the middle term being plus 12 times all that garbage, it was just plus 12a? And if that was the case, man, things would be so great. So let's just say that a is 3x plus 6. And if we say a is 3x plus 6, well then, this makes sense, right? And our first term, instead of being this, is actually going to be a squared. and then minus 28. All right? So now we have a quadratic trinomial, and we're ready to factor this bad boy. All we have to do is factor the trinomial. So I'm going to use mental math again. I got an A here and an A there. What two numbers multiply to negative 28 but add to positive 12? One's going to be positive, one's going to be negative. 28 is 7 and 4, right? But that's not going to help get us to 12. Is there anything else? And you look at 28, you're thinking, well, it's an even number, so how about 2 and 14, right? And if you're thinking 2 and 14, money. 2 and 14 is where we're at. It's a plus 12, so it's going to be a plus 14, and then the minus 2. And that's going to lead us to where we need to be. Okay, so that mental math process is fun in that method. So now we have our factored quadratic trinomial, and what we're going to do is switch back. Okay, because we said A is 3x plus 6. So we're going to switch back now. So when we switch back, we'll end up with, instead of A plus 14, we're going to have 3x plus 6 plus 14. And then instead of A minus 2, we're going to have 3x plus 6 minus 2. And all we have to do now is simplify, because that doesn't help us graphing at all. It doesn't help us with solving equations. So let's clean this up. So we're going to simplify each factor, and then we're done. Simplify each factor, and then we're done. All right. So in that first factor, 3x plus 6 plus 14 is 3x plus 20. And that's convenient, because now I don't have a common factor anymore. And then at 3x plus 6 minus 2, or 3x plus 4. And again, no more common factor. So we're good. We're done. That's going to be a beautiful setup for graphing or solving. So we're ready to go. All right. So that's the process of factoring with substitution. Okay. So what was the key element for factoring using substitution? It's focusing on that middle term. How can we get that middle term to fit into a quadratic model? And if you can have the middle term fit into the quadratic trinomial model, then we're good to go. Okay? So best of luck. I'll see you in the next lesson. Make sure you do your homework so you can practice, practice, practice. Peace.